Welcome student. Last video are discussing the different types of potentiometric titration. Then last seen the acid base titration, or it is also called as neutralization titration. Now in this video I see the redox titration. What is meant by redox titration? Redox titration means oxidation reduction reaction, which titration carried out the oxidation and reduction reaction. That titration is called as redox titration. See how to carry out the redox titration. For example, to determine the end point of ferrous sulfate solution and K2Cr2O7 solution. To determine the end point of titration between ferrous sulfate solution and K2Cr2O7 solution. Ferrous sulfate solution is also called as a reducing agent. And K2Cr2O7 is also called as oxidizing agent. Ferrous sulfate solution is the reducing agent, K2Cr2O7 is the oxidizing agent. In this ferrous sulfate, how to ionize this ferrous sulfate? It ionizes the Fe22 plus SO4 2 minus. Fe22 plus SO4 2 minus. This iron having two oxidation state. One is Fe22 plus and second is Fe3 plus ions. This iron having two oxidation state. One is Fe2 plus and another is Fe3 plus solution. Then how to carried out? Take a 100 ml beaker, solution of FeSO4 solution of FeSO4, and add this beaker some amount of H2SO4 solution. And in this beaker dip the platinum electrode. Take a 100 ml beaker, some amount of FeSO4 solution taken, and in this solution add the H2SO4 solution, and this both solution are stirred and this solution are dipped into platinum electrode, and this platinum electrode coupled with another cell. It is also called as a reference electrode. It is also called as saturated calomel electrode. It is also called as a reference electrode, and both are coupled with each other and connected with salt bridge. This is the experimental procedure. Take a 100 ml beaker, take an FeSO4 solution and some amount of H2SO4 solution. Both solutions are stirred, and in this solution dip the platinum electrode, and this platinum electrode coupled with another electrode. It is also called as saturated calomel electrode. It is also called as reference electrode, and both cells are connected with salt bridge. Then this is the experimental procedure. How to representation of this cell? Say the saturated calomel electrode. This is the negative end. This double line is called as salt bridge. Then solution, then oxidation reduction system. Then platinum electrode. Then this is the positive end. Saturated calomel electrode is the negative end. Then oxidation reduction system. This double line is called as salt bridge. And last is platinum electrode is positive end. This is the experimental procedure. This is the representation of the cell. With respect to platinum electrode, this is the positive end. That's why in this end it take place the reduction. See, with respect to platinum electrode, this is the positive end. That's why it take place the reduction. In reduction means gain of reduction means gain of electron, gain of electron, and oxidation means loss of electron. Redox titration means oxidation reduction takes place. With respect to platinum electrode, it is positive ion. That's why this is the reduction take place. See, Fe3 plus ions gives one electron to form the Fe2 plus ions. This is the reduction. This is the reduction. With respect to platinum electrode, this is the positive end. That's why this it take place the reduction. Fe3 plus already told that Fe ion having two oxidation end. One is the plus 2, another is the plus 3. That's why plus 3, Fe plus 3 plus electron gain. That's why Fe2 plus ion. This is the reduction take gain of electron. Then how to write this reaction quotient of this reaction? Qa is the reaction quotient is equal to Fe2 plus upon Fe3 plus. Reaction quotient written by product upon reactant Fe2 plus plus Fe3 plus ions. In this cell, how to write the Nernst equation? Nernst equation, see, E is equal to E0 minus 0.0591 upon n log of reaction quotient means Fe2 plus upon Fe3 plus. Fe2 plus ions and Fe3 plus ion. This is the n means number of electron take part in the oxidation and reduction. Here only one electron is there. That's why E0 minus 0.0591 log of Fe2 plus upon Fe3 plus ions. This is the Nernst equation for this reaction. It is in general, it is write as E is equal to E0 minus 0.0591 upon n log of reduction upon oxidation. Reduction upon oxidation. Fe2 plus ions converted into Fe3. That's why this is the reduction and oxidation reaction. Then it is a E is equal to E0 plus 0.0591 upon n log of this is transferred to Newton. That's why oxidation upon reduction. This is the Nernst equation of this reduction. Nernst equation of this reduction. Then how to carry out the experiment? How to carry out the experiment? Already you to experiment that this is the beaker FeSO4 solution and H2SO4. In this beaker, there are FeSO4 means Fe2 plus ions and SO4 minus ions. In this beaker having there are Fe2 plus ions and SO4 ions are present. Whenever the addition of oxidizing agent, K2Cr2O7, whenever the addition of oxidizing agent in this titration, there are oxidizing agent is K2Cr2O7. Whenever the addition of K2Cr2O7 in beaker, then this is the oxidizing agent. Means this Fe2 plus ions converted into Fe3 plus ions. This is the oxidizing agent. Whenever the addition of this K2Cr2O7, this in this beaker having Fe2 plus ions, this Fe2 plus ions converted into Fe3 plus ions means here oxidation take place. Means Fe2 in this beaker Fe2 ions are decrease and Fe3 ions are increase. Fe2, whenever the addition of K2Cr2O7, Fe2 plus ions are converted into Fe3 plus ions means in this beaker decrease the Fe2 plus ions and increase the Fe3 plus ions. Then how to represent the graphical representation? For classical method, here volume of K2Cr2O7 and EMF in potentiometric titration to measure the EMF of any titration. To measure the EMF of any titration. I already told that EMF is depends on concentration of ions present in the solution. Concentration of ions present in the solution. Whenever increase the concentration of ion, EMF also increase. Whenever the concentration of ions are decreased, EMF is decreased. In this titration, Fe3 plus ions are increased. Fe3 plus ions are increased, means concentration of ions are increased. That's why EMF also increase. EMF also increase. Initially EMF is slowly increase. Then near the equivalence point, EMF is sharply increase. Initially EMF is slowly increase, and near the equivalence point EMF is sharply increase. After the equivalence point again EMF is slowly increase. This straight line or sharply increase the EMF is also called as end point of titration, or it is also called as equivalence point. The sharp increase of EMF, this point is called as end point of titration or equivalence point of titration. Whenever the addition of K2Cr2O7, Fe2 plus ions are converted into Fe3 plus ions. Means in this solution, in this beaker, Fe2 plus ions are decreased and Fe3 plus ions are decreased. Whenever the concentration of ions are increased, the EMF also increase. Means Fe3 plus ions are increased as well as EMF also increase. Then this is the classical method to determine the equivalence point of titration. Means in this titration EMF also increase. This is the classical method to determine the end point of titration. Then next point is analytical method to determine the end point of titration. Analytical method to determine the end point of titration. Analytical method to determine the end point of titration. Then analytical method same. Here volume of K2Cr2O7 and here delta E upon delta V. In x-axis delta E upon delta V. What is the graph of this analytical method? Here EMF is slowly increase and after sharply like this. This is the end point of titration. This is the exact or correct end point of titration. Analytical method used to determine the exact end point of titration. This is the redox titration. A redox titration means oxidation reduction reaction. In this titration used for FeSO4 and K2Cr2O7. FeSO4 is the reducing agent, K2Cr2O7 is the oxidizing agent.